Europe's most active volcano is doing something it is not supposed to do. Mount Etna erupts several times a year, far more often than the rulebook allows, and it produces a kind of lava that should not be possible for a mountain its size. For decades, geologists could not even explain how it formed. It fits none of the three categories every other volcano on Earth belongs to, and when researchers finally traced where its magma actually comes from, the answer was 50 miles straight down, from a place that magma almost never escapes. Right now, as you watch this, Etna is erupting. The phase that began on August 6, 2026, has run for days without stopping, which reporting has described as a phenomenon unseen in Sicily since the 1970s. Ash has closed Catania Airport again and again, and the man who runs the observatory on its slopes has offered an explanation for the strangeness of it that points straight down into the mountain, which is where a study published a few months earlier had already been looking. Start with the problem, because it is older than any of this. Every volcano on Earth is supposed to fall into one of three groups. The first is mid-ocean ridge volcanism, where plates pull apart and magma rises to fill the gap. The second is hotspot volcanism, where a plume of hot mantle burns up through the middle of a plate. That is Hawaii. That is Yellowstone. The third is subduction, where one plate dives beneath another, drags water down with it, and melts the rock above. That is Mount Fuji. That is Mount Rainier. Etna should be the third kind. It sits where the Ionian plate is grinding down beneath Eurasia, and geologically that is a textbook subduction setting, but the lava is wrong. Chemically, what comes out of Etna does not look like subduction lava at all. It looks like the alkaline lava you get in the middle of a plate, thousands of miles from any collision. And it comes out in quantities and at a frequency that no ordinary alkaline volcano manages. Etna is more than 10,800 feet, 3,300 meters of mountain, more than 500,000 years old, and it erupts several times a year. Alkaline magma is not supposed to be able to do that. So for decades, Etna has been the volcano nobody could file properly. In April 2026, a team from the University of Lausanne, working with Rosa Anna Corsaro of Italy's National Institute of Geophysics and Volcanology in Catania, published a proposal in the Journal of Geophysical Research, Solid Earth. Their title describes the idea better than any summary. They called Etna a leaking pipe. Here is what they mean. Around 50 miles, 80 kilometers down, near the top of the mantle, there is a layer geologists call the low-velocity zone. It is named for what seismic waves do there. They slow down. The standard reading of that slowdown is that the rock in this layer is not entirely solid. It holds small fractions of melt, scattered through it, and that slipperiness may be part of what allows tectonic plates to slide over the mantle at all. That melt is everywhere. It is under most of the planet. It almost never comes up. What the Lausanne team argue is that beneath Sicily, it does. As Africa presses into Eurasia, the plate flexes and fractures, and those fractures reach deep enough to tap the layer. Magma that has been sitting in storage down there for a very long time gets squeezed upward through the crack, reacts with the rock on the way, and arrives at the surface as Etna, not melted fresh by a subducting slab, not delivered by a hotspot plume, leaked from a reservoir that was already there. And if that is what is happening, Etna is not a subduction volcano that behaves oddly. It is something else. There is a name for the closest thing we know of. Petit-spot volcanoes, first described by Japanese geologists in 2006, off the coast of Japan, where a flexing plate cracks and taps melt from below. They are the only known example of this mechanism producing actual volcanoes. And here is the part that makes the comparison strange. Petit-spot volcanoes are tiny, a few hundred feet tall, submarine bumps on the seafloor. Etna is a mountain you can see from space. One petrologist not involved in the research Sarah Lambert at the University of Utah told Live Science the finding represents a new type of volcanism. Now, the honest caveats, because this is a proposal and not a settled fact. The paper is new. The authors themselves write in the language of maybe. Lead author Sebastian Pile says the study suggests Etna may have formed through a mechanism similar to the one behind petit-spots. Nobody has drilled 50 miles down to check. What exists is a chemical argument, a tectonic argument, and a very good fit. Other researchers will now spend years trying to break it, which brings it back to the mountain that is erupting as you watch. The activity that intensified on August 6, 2026, was not unusual in kind. Etna produces lava fountains regularly. What made this one stand out was that it did not stop. Salvo Gambino, who directs the Etnean Observatory in Catania, told Euronews that similar phenomena were seen in the late 1970s, but that in recent decades these episodes have typically lasted a few hours to half a day. This one ran for days. His suggested explanation, offered while it was still going, was magma rising from greater depth and richer in gas. Deeper magma, which is not proof of anything. But it is the observatory director, watching the volcano in real time, reaching for the same direction the Lausanne paper points. It is worth being clear about what this eruption is and is not. It has been disruptive rather than dangerous. Ash pushed south by the wind shut Catania airport repeatedly and disrupted well over 1,000 flights during the busiest travel weeks of the Italian summer. The lava has stayed inside the Valle del Bove, the great collapse scar on the eastern flank, and has not threatened inhabited areas. On August 16th, monitors lowered the aviation alert from red to orange. Around 1 million people live on Etna's slopes, and they have lived alongside this for a very long time. They also get some warning. The last comparable event came on June 2nd, 2025. Etna threw an ash column roughly 4 miles, 6.5 kilometers into the sky. Part of the southeast crater collapsed, and an avalanche of hot rock and debris ran down toward the Valle del Bove. It was not a surprise. Monitoring had already flagged the activity, and warnings went out that morning. That is the current state of the art. Hours, and they may be about to get more warning than they have ever had. In October 2025, a separate INGV team led by Marco Firetto Carlino published a study in Science Advances on something called the B value. It is a simple ratio, small earthquakes against large ones, and it shifts as stress builds inside rock. They ran 20 years of Etna's earthquake catalogue through an updated statistical model, sorted by depth, and found the B value, tracking magma as it climbed through the plumbing. The useful part is the timing. Those shifts can appear months before the gas sensors detect anything, not hours, months. So the mountain nobody could classify may turn out to be tapping a layer that sits under most of the world, and the people who study it are only now learning to read it in advance. Which leaves a bigger question. If Etna really is a new, fourth kind of volcano, fed straight from the mantle in a way we are only starting to understand, how many other ordinary volcanoes might quietly work the same way and simply have not shown it yet? Where do you think the next one is hiding? Tell us in the comments. The layer is under almost all of us. Etna is just the one that leaks.